Hey, pre-calculus, since I can't be here today, I wanted to make a video just kind of going over the big ideas from section 212. So let me share my screen. It's been a while since I've had to do this. Let's make sure I do it right. All right, let me pull this up here. So first of all, you just did that Desmos activity. And in that Desmos activity, you learned about how if a graph has reflection symmetry over the y-axis, we're going to call it an even function. And if a graph has 180-degree rotation symmetry about the origin, we're going to call it an odd function. So that's what you were just seeing when you did that Desmos activity. And now what we want to do is we want a way to algebraically determine whether functions are even or odd, or it's possible for them to be neither. So if it doesn't have reflection symmetry over the y-axis or 180-degree rotation symmetry about the origin, then it's neither. So not everything is one or the other. Make sure that you have somewhere in your notes what it means for functions to be even and what it means for them to be odd. And to determine if they are even or odd algebraically, what we're going to do is we're going to compare the original function to the function of the opposite of x to the opposite of the function. So in an even function, what we're going to see is that f of x is equal to f of the opposite of x. Okay, make sure that's in your notes. In an odd function, we're going to see that f of the opposite equals the opposite of f of x. You're probably like, well, those look really, really similar, but they're not necessarily always the same. So we're going to look at a couple of examples to see why this works. So when we look at this right here, it's the parent function for a parabola, and we should be looking at the graph and saying, okay, yeah, that's even. I can see that I have reflection symmetry over this line here, just the y-axis. So this is not drawing very nicely at all, but there, right, we have reflection symmetry. So what we want to show, what we said for things that are even, is that we want to show that f of x equals f of the opposite of x. So let's first just figure out here, what does f of negative x look like and what does the opposite of f of x look like? What does that even mean? So f of negative x, remember, means that in the f rule, in place of x, we're going to substitute in negative x and we're going to simplify. So this would mean that we are going to do, in place of this x, I'm going to put in negative x. Notice I'm putting it in parentheses and square it. So f of the opposite of x. Now when I square a negative, it comes out to be positive x squared. So do you see how the original function is equal to the opposite of x? So that means, like, if I were to put 1 in here, like if I put 1 in, I get 1 out. If I put negative 1 in, I also get 1 out. If I put 2 in, I get 4. If I put negative 2 in, I get 4. So you meant you had reflection symmetry over the y-axis. It means like all the values, all the graphs have to be like, all the points have to be like up top so that you can reflect it, or everything's both on the bottom. So when you reflect it, they're the same. Now, when it says the opposite of f of x, that means I'm taking the opposite of my f of x rule, which this would just be the opposite of x squared. Okay, these are different things. This means square it and then take the opposite. This means that whatever this number is times itself. So since f of x is equal to f of the opposite of x, f of x is an even function. All right, so now let's look at one where we know it's odd. So this is x cubed, and if I rotate this, this is one of the examples that was in Desmos. It would land right back on top of itself if I rotate it 180 degrees about the origin. So what I had set up here is if things are odd, it means that f of the opposite of x is equal to the opposite of f of x. All right, so let's see what I mean by that here. So f of the opposite of x means, again, that I'm going to, in my f rule, in place of x, I'm going to substitute in negative x. So I would have in parentheses negative x cubed. Okay, so when I do a negative x times negative x times negative x, the product of 3 negatives is negative, so negative x cubed. Okay, the opposite of f of x means I'm going to start with the opposite of whatever my f of x rule is, which is x cubed. So the opposite of f of x is negative x cubed. See how these are the same thing. So what this is saying is like, okay, here I have 1. Now it's saying when I put in the opposite of 1, like here I got 1, 1. Here I'm going to get negative 1, negative 1. The value is going, the y value is going to be the opposite of what I had originally. And that is like that result of, it's a rotation. So if I put 2 in and I got 8, okay, this is saying if you put negative 2 in, you should get negative 8. Okay, so if it's odd, then that is the pattern that we would be seeing. So in general, if you're trying to figure out if something is even or odd, the first thing you could do is you could graph it or think about, I know what the parent functions look like, and this would be, this would have reflection symmetry or not have reflection symmetry. You'll also be asked to algebraically explain. Okay, so for this one, I should be saying as a conclusion, since f of the opposite of x equals the opposite of f of x is an odd function. Okay. So for example 3, this was one of our parent functions from way back at the beginning of the year, which you may or may not remember. This is what it looks like. You don't necessarily have to graph it, but sometimes it gives you an idea of if it was even or odd. And so for this one, if I want f of negative x, that means in place of the x here, I'm going to substitute in negative x. So I would have 1 over, and then in parentheses, negative x squared. Notice every time that I'm substituting in a negative x, I'm putting it in parentheses. And then I get negative x times negative x is x squared. If I see how this is equal to our original, then that means it's even. Okay, if we wanted to figure out what this is, it would just mean take the opposite of f of x. Well, that would just be negative 1 over x squared. These are not equal, so it's not odd. Okay, these are equal. So, whoops, didn't want that. Those are equal. So that means that they're even. So since f of x equals f of the opposite of x, f is an even function. All right, so see if you can try example 4 on your own. See if you can, you could look at the graph and say, okay, yes, I think this is even or I think this is odd, but try to algebraically explain why it is even or odd or neither. All right, so again, f of negative x means in place of x, I'm going to substitute in negative x. So in parentheses, I have negative x to the 5th and then plus 1. If I have an odd number of negatives, then overall it's going to be negative. So comparing these two, those are not equal, so it's not even. If it's odd, these two things will be equal. So this means take the opposite of f of x. So take the opposite of x to the 5th plus 1. Okay, so then this is equal to, if I distribute, negative x to the 5th minus 1. These are not the same. These are not the same. So this is an example of neither. So since f of x doesn't equal f of the opposite of x, and f of the opposite of x doesn't equal the opposite of f of x, f isn't even or odd. All right, and then for my last one, I meant to scroll. All right, so for our last one, so when we look at this, you might be able to tell if it's even or odd. I definitely know it's not even. Obviously, if I flip this over, it doesn't land. It sort of looks like I could turn it. But when you look at this function, you really wouldn't know off the top of your head probably if it's even or odd. So let's go ahead and go through this process. So f of the opposite of x. So in this one, in place of all of my x's, I'm going to substitute in a negative x. So I will have in parentheses negative x squared minus 3 over negative x cubed minus 2 times negative x. So when I simplify, a negative x times a negative x is a positive x squared minus 3. And on the bottom, this would be a negative 3 negatives, right? So this would be negative x cubed. And then minus, and the negative would be plus 2x. So when I look at, oops, 2x, I said it but didn't write it. When I compare this to this, those are definitely not the same. Top is, but the bottom isn't, so it's not even. So now I'm going to figure out, well, what is the opposite of f of x? So the opposite of this whole x squared minus 3 over x cubed minus 2x. Now, when you take the opposite, some people are like, oh, I'm just going to flip the signs on everything. Well, really, when you're taking the opposite, it's like you're multiplying by negative 1 over 1. So if you multiply across the top, it takes the opposite of the top, right? But on the bottom, it's just staying x cubed minus 2x. So now when you look at it and you're like, well, are these equal? Just looking at it, you're probably like, well, no, they're not equal. So what we want to do is we want to manipulate this a little bit to see if we can get it to be equal. And so here, if I want these to be the same, it's kind of like the signs are all sort of flipped around. So what I'm going to do up here is up here, I'm going to pull a negative 1 out. So then I have x squared minus 3. Right, you see this times x squared is negative x squared, this times this is a plus 3. Okay, and then I have x cubed minus 2x. It's like, these aren't really, it's still not the same. But this negative 1, this is like having like negative 1 and then having a 1 here. Really, this negative 1 can go on the top or the bottom. So I'm going to kind of flip it around. I'm doing a little bit of math magic here, a little creative simplifying. So on top now I have x squared minus 3. And now on the bottom, if I distribute this negative 1, it's like you can have the negative 1 on the top or the bottom, it doesn't matter. Do you see how these are now the same? I just did a little manipulating. So since f of the opposite of x equals the opposite of f of x, f is an odd function. Okay, so those are the big ideas that you need to get out of this section, the difference between even and odd. Make sure, if you haven't already, that all of this is in your notes.